Okay, done. Hello. Good morning, boys. Good morning, boys.
Good
Good
morning,
morning,
ma'am.
ma'am.
Please read. Please start reading better.
Ma'am, I read.
Okay, ma'am.
Ma'am,
Yes.
I
Yes, better.
Measurement of
measurement of
time. Measurement of time.
Who is
Time.
reading?
Time is measured
Just a
by
moment. Who
using
is reading?
clocks
Just tell me
or
your name.
watches.
Tell me your
Kasim
name.
Reza.
Huh?
Mehdi Reza.
Mehdi Raza and
Mehdi.
Kasim. Okay, the other one is
Kasim.
Kasim. Okay, right now Mehdi read and next slide Kasim will take on. Okay?
Okay, ma'am.
Okay, start.
Measurement of time. Time is measured by using clocks or watches. Clocks and watches makes us of periodic motions. Wall clock, table clocks, wristwatch watches, digital clocks,
That's it. So,
etc.
yeah. So, what is measurement of time? How do we measure time? By using clocks or watches. What is the motion which is available in clocks and watches? It is periodic motion. Because periodically we are having seconds, we are having
Pendulum
minutes,
motion.
and as well as the hour. So it's
Pendulum
all periodic.
motion.
Wall clocks you can see over here.
Yes,
Those
they have.
always use. Beta, let me finish. Then you will speak. Okay, beta? Hello. Did you get me? Let me finish. Then you will speak. Okay.
Okay, okay.
So wall clocks we have over here with pendulum. Then we have a table clock, or you can say alarm clocks. Then we have the watches, the wrist watches. Then we have these are the digital clocks that you put in on the table, and we have got a digital watches also. Can you see this? This one is digital watches, and we have the wall clock without pendulum. So this is with pendulum,
Yes,
and this is without pendulum. Nowadays we use without pendulum. Yes or no?
yes,
Yes.
Yes,
In olden days, like in the grandpa's houses, you can see the clock with the pendulum. Old clocks there. Nowadays, pendulums are not being in use. They use, they don't use it at all. The pendulums are gone these days. Now everything is digitalized. Can you see this? They all are having digital watches. This is digital watch, and these are digital clocks. Most of them are using digital instruments. Okay, now we'll see the points to remember or summarize. Yes, Kasim.
Yes, ma'am. Points to remember. Simple pendulum. A simple pendulum consists of a small metallic ball called bob, suspended from a rigid stand by a thread. When the bob of the pendulum is released, after turning it slightly one side, it begins to
Begins.
and fro. And the to and fro motion of a simple pendulum is an example of an os- oscillatory
Oscillatory.
or a periodic motion.
Okay, thank you. So what do we have to remember? The simple pendulum. What is simple pendulum made up of? Simple pendulum has got a
metallic.
thread. It's got a thread. And then it has got a metallic ball which is
Ball.
known as, yes,
Bob.
what's happening? Which is known as bob. This is known as bob. Got it? This metallic ball is known as bob. Okay?
Yes.
Now, this is suspended to a rigid stand. It should not fall because it is heavy. This is a pendulum. What it is? Pendulum. Now, I take this bob of the pendulum to one side. one side, and leave it, release it. It comes here, then again it goes here, it will come to this side.
And
You
without
agree?
power also it moves.
Yes, yes, it moves. It moves from one end to other end.
Years and years.
And it starts oscillating. It begins to move to and fro. It starts oscillating or periodic motion. So, which is the motion that it
Yes.
will follow? It will have the oscillating motion
Periodic
or the
motion.
periodic motion. Any problem? Do you find any problem in understanding better?
No, ma'am.
No. No.
Now, please read.
Yes. Simple pendulum.
I'm read.
Who is it?
Mother,
Who is it? Be louder, beta. Who is it? Who wanted to read? Can you
Kasim.
help me with?
Kasim.
Kasim has already read it, isn't it? Someone else will take on the charge.
Yes, ma'am.
Read, beta. Sahil, you read otherwise.
Okay, ma'am. A simple pendulum has small metallic bob
Don't
suspended
repeat.
from
Don't repeat, please.
suspended from a stand by a thread. If the bob is taken to one side and released, it moves to and fro. The the to and fro motion of the simple pendulum is called periodic motion of osci- oscillatory motion.
Fine. Now, this is a simple pendulum. You
Yes.
agree? Yes, a simple pendulum, this one. This is a stand, this is the thread, and this is the bob. Yes or no?
Ma'am, but in the clock there are wooden.
Doesn't matter. It's a something is inside, isn't it? It's a wooden. What I'm talking, it's a simple pendulum to begin with, just to show how the movement takes place. Now, in
Hello.
the wall clock, I can take it my ways. I can take anything. I can take wooden string. I can take metallic string. I can take anything what I wish. Yes or no? But just for the experimental sake, I am trying to tell you how the pendulum looks. That's why I said it is a simple pendulum. Now I take this pendulum onto one side, right? Which position? A position. And then release it. So it comes back here, then it goes to B. So it comes to B. You agree? And then again it will go back. Now this position going back here and then coming back from A to B is called one oscillation. Do you follow me?
Yes.
Yes? Okay. Now you look over here. The bob was here, isn't it? Earlier the bob was here. What we did? We took it to one side on the A. We took it to one side. So A. And then we will release it. What we will do? We will release it. See. This is central position. This is the central position. And this was A position. Yes? Then when we release it, it goes to B position. You agree? So this is central position, this is A position, and now it has come to B position. Yes, please read. Sanraj, is he there?
Yes, ma'am. I
Ask
am
him to
here.
read, beta. Okay, ask him.
What?
Read, beta.
Okay, read. Oscillation.
Oscillation.
When, oscillation. When the bob moves from the mean position O to A and to B and back to O, it is called one oscillation. When the bob moves from a extreme position A to the other extreme position B and back to A, it is called one oscillation. Time period. The time taken by the pendulum to complete one oscillation is called its time period.
Okay. Now, this is the mean position. So when the bob moves from O to A, yes, and then back to B, and again coming back, this becomes one oscillation. Rather, you can say when the bob is moving from here, going back, and again coming, that is called as one oscillation. Okay? So what you will say?
Okay.
A to B and B to A is one oscillation, right? So these are the extreme position, and this is periodic. Okay? Okay, beta? So this is one oscillation. Now what is time period? Now the time taken to complete one oscillation. How much time is taken to complete this oscillation? One oscillation is called as time period. Understood?
Yes.
Yes. So time taken to complete one oscillation is equal to time period. Any problem? Any problem, beta?
No,
Now we'll see
ma'am.
points to remember. Please.
Okay, ma'am. Points to remember. One oscillation. The pendulum was said to have complete oscillation when each bob
Completed
moves
one
from.
oscillation, beta. Completed
Yes,
one
one
oscillation.
oscillation. Yes. When
When
each
it
bob moves from one extreme position A to the other extreme position B and come back to A. Time
yes.
period. Time taken by the pendulum to complete one oscillation is called its time period.
Yeah,
Time
that's it.
period
No,
can.
that's it,
Okay.
that's it, that's it, that's it.
Okay. Okay.
That is calculation. We don't have to do the calculation, right? We have to only talk about the time period. That was formula, so we don't require the formula. It's not in your syllabus. Now, what is one oscillation? We just saw that extreme position from A to B and back from B to A is called as one oscillation. The time taken to complete one oscillation is called as time period. Is it clear? Is it clear, better? Hello?
Yes.
Yes. Now we will do an activity to measure the time period of a simple pendulum. Please read.
Yes. To measure the time period of simple pendulum, set up a simple pendulum with a thread of length about 1 meter. Move the bob to one side and release the bob. Measure the time taken to complete 20 oscillations using a stopwatch or a stop clock. Record the observation in the table. Repeat the activity 3 times and record the observation. Find the find the time taken for a oscillation. The time period is nearly the same in all cases.
So what we observed that we will do this activity, the time taken for 20 oscillations will be almost same. What observations they got? That take 20 oscillations. Now do one activity, count 20 oscillations and find out the time. It's they have done 3 times, 4 times, 10 times. They found more or less the time taken for those 20 oscillations is almost the same. It never changes. Understood, beta?
Yes, ma'am.
Yes.
Yes? So observations were same. They kept on
Same.
repeating the activity 3 times, and when they recorded the time, they found that it is more or less same. Now we will see what are the units of time and speed. Please, better. Please read. Hello?
Yes, ma'am.
Start reading, better.
Okay, unit of time and speed. The basic unit of time is seconds. The large unit of time are minutes, hours, etc. Number B. The basic unit of speed is meter per second. A large unit of speed is kilometer per hour. Number
So you agree? Just a
okay,
moment.
number
You
6.
agree? Just a moment,
Yes.
better.
Okay.
You agree to this? So what is the smallest unit of time?
Second.
Second. Is someone's mic is on? What is the larger unit of time? Minutes, hours. You agree with these two?
Yes, ma'am.
Basic unit of speed is meter per second, m oblique s. The bigger unit is kilometer per hour. Agree? Do you know or don't you know? Hello?
Yes, ma'am.
Yes?
Read.
Now we will
Asian time
see
measuring device.
devices.
Same as
Some.
devices. Some Asian time measuring devices were
I can
sundials,
hear someone's
water
sound.
clocks, and
Hello, just stop it. Just stop it for a while. Just check whose mic is on. Now start.
Asian time measuring devices. Some Asian time measuring devices were sundials, water clock,
Dials.
and sand clock.
Okay. So some very old measuring devices. They were sundials, water clocks, and sun clocks. See one by one.
मैम ये
This is
सैंड क्लॉक
sundial.
तो सुना ये दोनों क्लॉक नहीं पता
Yes, and I sun.
Just a moment. Don't speak like that.
बस साहिल आराम से
Both of you don't speak like that, please. I request both of you. First of all, you will not speak in Hindi. Secondly, you will not shout.
Okay, have I explained?
Yeah. So let me explain first, and if you think that you've got extra, then you explain. Will it do?
Okay, ma'am.
Thank you, beta. Because you are already behind, beta. Girls have finished this chapter. So let me finish it fast so that both of you can be together. Here you can see the sundial. You can see the shadow over here. Can you see the shadow? Can you see
yes
this shadow?
ma'am
Yes.
yes
Due to this shadow, they find the time. This is sundial. And you can see the numbers, they are all Roman numerals. Can you see this? These are all Roman numerals. Yes? 3, 4, 5, 6. They are all Roman numerals. Now it has got the water, which was not in use, much in use. Then we have the sundial. Sorry, the sand clocks. It takes almost 1 hour or maybe emptying the container. Now, someone wanted to explain. Is it you, Sanraj or Sahil, who wanted to explain? Yes? Sanraj or Sahil, who wanted to explain better? Hello, boys. Who wishes to explain these measuring devices? Who wants to explain the measuring devices better?
Okay. Hi.
Okay, say.
The shadow of the sun works like clock. The
Okay.
hand of the clock.
Okay. Then
The shadow of the clock is sun and moon and the sun when earth rotates.
okay, good. Then continue better. You're doing nicely.
Shadow of the sun. This rod shows the time.
Mhm.
Ma'am, in which direction this rod faces? It is tilted.
Huh, better?
In which direction rod
You're
faces?
not clear. You're not clear. Speak softly,
In which
slowly.
direction this rod is tilted?
No, it is fixed. There is no direction, so it is
No,
fixed.
ma'am.
See, you can see it's over here 0. Can you see this? Just a moment. Here, it is fixed at the 0 position. Can you see the 0 position?
Ma'am, but in which direction? North, south, east.
No, it all depends. Doesn't matter. In any direction it can be. Because the shadow will be casted on it. The time measurement was done by the shadow, not by the direction as such. You getting it now? Yes? Okay. Now we'll see how to measure speed. Please start.
Okay, ma'am. Measuring speed. The speed of an object can be measured if we know the distance covered by the object and the time taken. Example: if a car covers a distance of 100 kilometers in 2 hours, then the speed of the car is
What
distance
is
covered
given?
100 kilometers.
What is given? Distance,
Yes,
which is
distance.
100 kilometer. What is the time? 2 hours.
Big
So what is speed?
2 hours.
What is speed? Distance upon
Uh,
time.
Distance
What is the
upon
formula of
time.
speed? Distance upon time. What is distance? 100. What is time? 2. So what answer we will get? 50 kilometer per hour. You understand? I hope you know how to solve. Yes? Yes, beta?
What, ma'am?
I hope you know how to do the numericals.
Yes.
Read.
How to measure speed? ये नहीं समझ आया.
Hmm? I told you not to speak in Hindi, did I?
How to measure speed? I didn't understand that.
Okay. Distance you know, 100 kilometer. Time you know, 2 hour. What is the formula of speed? Distance upon time. This you know? Speed is equal to distance upon time. I have taught you earlier. Remember?
Speed didn't.
Yes. So distance is 100. Time is 2. You divide
Yes,
it, you get
ma'am.
50 kilometer per hour. That's it.
Ma'am, we have to divide or.
Yes, you have to divide.
Okay, ma'am.
Now please begin. Please continue.
Am I read?
Yes.
Am I read?
Yes, beta. I said yes.
If we know the speed of the car and the time, we can find the distance covered by it. Distance is equal to speed into time. 50 into 2 is equal to 100 kilometer. If we know the distance
Now you
covered by the
understand?
car,
Now you
if
understand if you know two units, if you know two values, you can find the third value. Earlier we found out speed, right? Now we are going to find out distance when speed and time are given. Then we will find out time if distance and speed will be given. Do you understand?
Yes.
Boys? Okay, fine. Read. If you know distance,
Yes, ma'am. Time is equal to distance upon speed. Distance is equal to 100 kilometers and speed is 50 kilometers per hour. So we divide it, we get 2. 50 2 is 100. 0 equal to 2 hours.
understood? So kilometer gets cancelled and we get hour. So time is 2 hour. So the two values should be given, we can find the third value. Okay? So distance we got time, earlier we got speed. So first we found was speed, that was the first one, second is distance, and third is time. So remember in the question itself, what was given? Distance 100 kilometer and time 2 hour. Just have a check, see. Distance covered 100 kilometer, time is 2 hour. That was given. So now it is finalized that your answer is correct.
Yes.
Yes? So all of you understood better?
Yes.
yes,
Yes.
Now we will read
points,
the summary. Points to
point,
remember.
points to remember: unit of time and speed. The of basic unit of time is second. Its symbol is s or second. Sec. The basic unit of speed is meter upon s.
Per
Meter
second. What do you say? Meter per second. Okay? So what is the base unit of time beta? It is second. Symbol is S or SEC. And the speed unit is meter per second. Now read this.
speedometer. It is a device to record speed. It records the speed directly in kilometer per hour. Odometer is a device to measure the distance covered by the vehicle.
Okay. So what is speedometer? So on the dashboard, that is on your car, not on your car, in your car, on the dashboard near the steering wheel, you have these devices, the speedometer and odometer. Just keep a check. Just have a look over there and you will understand. The speedometer is obviously, as the name suggests, it has to do something with speed. So what it does, it records speed directly in kilometer per hour. So what is the unit for recording speed with a kilometer per hour?
Kilometer per hour.
There's another unit which is known as odometer. It measures the distance. How many kilometers your vehicle has covered directly. You understand?
Yes.
Yes? Okay, thank you. Now see how this looks over here. The same thing. Now you can see over here speedometer. Can you see the
It is
speedometer?
in bike also.
Yes, on the bike also. Very good. So you're an observant. Very good, beta. So you can see this speedometer beta, kilometer per hour.
Yes.
Yes. And in this case, both are
This
inbuilt.
black and white
Speedometer and
number.
odometer, both are there. Yes, both are there. This is kilometer per hour, and the speed that you can see is not sort of speed, the distance. It is over here. Got it? The distance covered.
Yes.
This is again, you can see the speedometer, and here is C.
Both.
This is a speedometer and both are there. This is the speedometer. The upper one is the
Speedometer
speedometer.
and odometer.
This kilometer per hour. And odometer is this kilometer. Can you see this?
Yes.
This much of kilometer your car has traveled or your mobile has traveled.
And my mobile also there is speedometer.
Yes, it
Points.
has.
Graphical
It has better.
respiration,
Representation.
representation of data. We can represent the data in
Pictorial.
pictorial from
This is a bar graph.
by three ways.
Three
One,
ways.
bar graph. Two, pie chart.
Chart.
Three, line graph.
Okay. Now, if I show you, what is this called as?
Bar graph. Bar graph.
Bar graph. Exactly.
Bar
This is
graph.
called as bar graph. This is called as circle. This is called as pie. What it is called as? Pie chart.
Pie graph.
Pie chart
This is
and
called
this
as
is line
line. This is called as line chart.
line graph.
Understood? Who is that who is saying bye? Who is it, beta? Who is saying bye, beta?
Muhammad Ali मैंने किया.
Send me his number in the WhatsApp, okay?
Okay.
Okay. We'll finish this and then we'll call it a day. Explain,
Point
beta.
number. Motion of an object can be represented in
Represented. Read it like represented.
represented pictorial form by the distance time graph. The distance time graph for the motion of an object moving with a constant speed is always a straight line.
For example, what is this? This is uniform speed or the constant speed. You can make out. In the second one, it is going slow and then it increases the speed. Yes or no?
Increasing speed.
Yes.
Yes? Okay. Here the time is 1 hour, the time is 2 hour, time is 3 hour. The distance is the same, that is 20 kilometer. That means it is at rest. Your vehicle is not moving. This much have you understood?
Yes.
All of you?
Yes.
Yes? Yes or no, beta?
Yes.
So, just a moment, this is the last slide. Can we finish it, beta? Here I can show
Yes.
that this is the distance time graph and you can see the straight line. Can you see the straight line? That shows that it is moving with a constant speed. And if the speed changes, then it could be like this, it could be like this, it could be like this, or straight. It could be like this if the speed is changing. But if the speed is not changing, then it has to be a straight line. Any
Constant
problem?
speed.
Yes. Any problem, beta?
No.
No.